Hello everyone, I hope you are doing good. My name is Uttaran and today I am going to show you the video editorial for problem number E in AtCoder Beginner Contest 233. So let's have a look at the problem statement. So the problem statement is we will be given an integer x and we have to find the value of the summation of x by 10 to the power k and the floor value of it, where k ranges from 0 to 10 to the power 100. Now x can be pretty large. That's the first thing we have to notice. It is a huge number. It is 10 to the power 5 into 10 to the power 5, so it's really huge. So we have to consider that, and that is the input format, just a number x, and we have to tell the summation of this function. So let's look at some sample input now. One more thing here, the answer must be precisely printed as an integer, so we can't have some modulus or something like that, even if it is large. So we can't have an exponential notation or something like in front of 0, so it should be like an integer how we write it. Now the sample inputs are given, so we will look at that, and we will also look what the floor function is actually. So before that we have look at the prerequisite for this problem. So it is how I solved it. You can solve it in any other way, but I solved it using prefix sum and some string concept here. It is basic string concept, just like the STL you need to do here. So I've copied the question here for my purpose, and let's look at some of the sample input. So suppose we are given the input of 1, 2 to 5. How do we find the value 1360 according to the question? Now we can see it, the first value of k is 0, so we will go like here. The first value will be 1, then it will be 10. That's the power of k increases as 0 is appended to the number, so it will go on like that. So this is the value of k. Now then, what we are seeing is we have to divide the x by it. So the first value will be 1225, just like the number, and then we will have to divide it by 10. So the number will be 122.5. Like if the number is 1225, by the next instance the number will be 122.5, and for after that the number will be 12.25, so 12.25, and then it will be 1.225, and then will be 0.1225. Now what does this denotes? What does this means? This means if we have some integer, like suppose 1.5, that corresponds to 1. Suppose if we have 2.34, that corresponds to 2. If we have an integer like 5, that should be 5 only. So whatever the integer value of before the point, so that will be the number. But if we have something like minus 1.5, it won't be minus 1. It won't be minus 1. It will be the value before it. So what we can say about this is this means sorry about that, this means the value, the integer value before this number. Okay, so we got the definition of this. So now let's not have this because we will need space, so let's clear that out. So we have this value, these are the values. So what will be the working values of our, so what will we add? So we will add this first, then we will add 1 2 2, then we will add 1 2 and 1 and then 0, and after that all the numbers will be 0, so we don't actually care about that. So as the output suggests, this will be 1360 at some point. So that will be the sum. Now the main problem is we can't do a brute force in here. Now we see why. The value of k is large, but what will be the actual value we will iterate through k? We have to check that, because 10 to the power 100 by computing power is huge, so we can't be compute that in what was the time? It was 2 seconds, so time limit is 2 seconds, so we can't compute that in 2 seconds. So what will be the value of k? What will be the maximum value of k? We'll look at. We can see for a 4-digit number we are going for only the first 5 k's and we don't need to do the other k's. So in general we need, suppose if length of x, so this means that the number of digit in x equals to n, we only iterate k in an order of O n. Now we know that the number of digit is in the order of log of that number. For an integer number, for a decimal number, I mean the number of digits in that number will be in order of logarithm based on 10 base logarithm. So if we base it on 10, so the number will be only this number, the number will be this. So we will iterate through at max this many numbers. Sorry for the inconvenience. So this will be our maximum. N. So we just see that we don't need to iterate for all of these case values. We just need at max 5 into 10 to the power 5, I guess. This is 5, right? 1, 2, 3, 4, 5. Yeah, 5 into 10 to the power 5. So that's the first observation. So the number, we have given the input number x, so it has to, the output, the code should be at some order of that number. So we can't actually take any order of that. So we can take the digits, we can iterate through some digit, and then we see that the digit of that is 5 into 10 to the power n. So we have to work on the digit. We can see that, and the complexity of that code should be something like order of log base 10, so log 10 of x. We can work with that, right? So we have taken some insight of this question and got some order of the complexity of the code. Now, by doing this kind of approach, we can see this will be order of n square. We can't really afford that, because order of n square will be, again, order of n, where n is the number of digit, will be slow, because n can be 5 into 10 to the power 5, so n square will be something like 25 into 10 to the power 10, and that will be large. We can't handle that in 2 seconds, so we have to optimize it somehow. Now let's look at what is happening actually here. Let's write those numbers in a vertical fashion. So how we add the numbers actually: 1 2 2 5, then the next number is 1 2 2, then the next number is 1 2, and then the next number is 1, and we don't take the 0. Now what we can see is there some pattern. We will look at that a bit later. Let's just take some zeros here, right? That will help our. Now the sum. What is the sum? We do the sum by this manner. Now 5 2 2 1, that's 10. So we have a 0 here, the 1 corresponds to this number, and then we have 2 2 1, so that is 5, and adding to that 1 is 6. Now we have 2 and 1, so this is 3, and this is 1, so we got the number. Just simple addition here. Now let's look at this number and try to identify something. What is actually happening here? Let's write this number reverse, in a reverse way. So 0001, then 0012, then 01122, then 1225, right? Now if we take this, if we take this portion only, what we can see? We can see the whole number, right? Let's just copy it, and then if we take this 3, we can see the first 3 digit of the number. Then if we take only this, we can see the first 2 digit of the number, and this is just the first digit of the number. So here we can conclude that in the sum, in the sum this digit will be the sum of the digits. The LSB, the digit in the 0th position. Let's have a, so this is the 3rd position, this is the 2nd position, this is the 1st position, this is the 0th position. Okay, have it here. Let me we have it here. So this is the third, this is the second, this is the first, this is the 0th position. So the number in the 0th position in the answer will be the sum of the digits, sum of all the digits. The first position, sum of the first 3 digits. The second position, sum of the first 2 digits, and the third position is 1. So if we traverse from the left side, we can see that this is actually the prefix sum. So let's just take 1 here, then we have 3, then we have 2 and 2 and 5, and then we have a 10. Now what is happening here? We can see the number is 1360, but we are getting 13510. So we will take the addition of this number in a different fashion. So this one is actually the carry. So we will take this one and forward to this. Now there is no carry, so we don't care. Then there is sum is 3, again no carry. There is 1, again no carry. Now we can use the idea of prefix sum here. We saw that there is, this is 1, this is 1 2, this is 1 2 2, and there is 1 2 to 5. So the number is actually increasing. So we can get this by taking the number 1 2 2 2 5. Suppose we take this and take the sum of it. So the prefix sum is this, then 3 adding in 5, and then we can add to it 10. So this is the prefix sum. Now when we got the prefix sum, let's traverse it from the end to the first, from the end to start, and we can check it that this is actually giving us the answer. So let's go to the, so this is 0, right? We have a carry of 1. So let's have an carry here, carry 0 first of all, and we put the 0. So carry 0, and we add 10. We take the least significant bit LSB, and we get 0 here. Now when we add this, the carry is 1, so we need to change this carry. So we can take this out and take the carry as 1 now, right? Now when we get the carry 1, if we add this to this value, so that will be 6. 5 plus 1 is 6. So we can add a 6 in here. So let's add that. Then the carry will be 0 again. So have a carry, we'll have a carry of 0, right? Then we can add 3. The carry will remain 0. As we can see, we are adding 3 and the sum is 3, so this will be 3, and here it will be 1, right? And that is our answer, 1360. Now how do we get this value? Let us check for 9999 the same manner. This is the solution approach, and we are going to apply exactly this algorithm in our code. So let's just have that. Now we can separate it in different number. Let's just have this as a number. Then what we can do is we take the prefix sum. This is gonna be 18, this is gonna be 27, this is gonna be 36. What do we have? We have 5, sorry, so that will be 9 and that will be 45, right? Now let's take the addition from the back. So let's just have 0 here, 0 here, because we are not initialized, we haven't calculated this, so let's have initialized with zeros. Now we have 45, so we take 5 here, and the 4 is our carry. Now we add 36 plus 4, so it is 40, so 4 is our carry. This bit got 0, so 27 plus 4 is 31, so 1 is be there, and 3 will be the carry. Now 18 plus 3 is 21, so 1 will be there and 2 will be the carry, and 9 plus 2 is 11, so 11 is there. Actually 1 is there, and because we don't have another number, so we will assume that there is zeros, so that will be the answer. The final answer is 111105. That's how we do it. Now how do we implement this? This implementation will be easy, but when the number is such big, just look at this number, this is huge. We can't fit this number into an integer, whatever the language is. We can't actually take these values in any language. We can do it in some language like Python, but the calculation will be very difficult in the time limit. So we will use a trick here. We can use strings here. As I said in the prerequisite, I used a string, so you need to use the string to actually show that number, to represent that number, because you can't hold it in some integer form. So now let's have a look at the implementation of this problem, rather this algorithm. So first of all, we have taken the x as string, and we are getting the input. So we have taken the variable n for the length of the x, and then we are creating the prefix array. The first value of the prefix array, as we know, the first digit x, the digit at the position x0, and then we are calculating all the rest of the prefixes values by adding its just immediate previous values and that digit. And we have taken the answer as a string also, because we are told that the values and input and output can both be enormous, so it is important to take the answer as a string. Then we are creating the carry variable as 0, and then we are taking the sum. So the sum will be this digit, the n-1 digit at the first iteration, and that carry. Now the carry is 0, so we are going from right to left, and then the prefix will be this value, and then the carry, but the sum will be, and then the digit is the rightmost digit of that sum value. So we are taking the remainder of this after dividing by the 10, and the rest of the number will be the carry, and we are taking that digit to string, as we are storing that information in the string answer. The answer variable is in string, so we have to convert that to string, and we can do that by toString. That's the standard function in C++. So we are taking as temp, and we are adding that to our answer. Now this is an important part. If suppose we have taken all the n digit and we have calculated it, now there can be a carry. Suppose in this we have taken all the 5 digits 1 2 3 4 5, and we had a carry of 1. Now if there is a carry, we need to do this. But why if only carry? If carry is 0, then we don't take it. But why? because in the question it was mentioned that it is not allowed to print unnecessary leading zeros, so we can't take the carry if it is 0. So we are checking if only this if condition will only be executed if the carry is greater than 0, and then we are simply adding that to our answer. Now we are reversing the answer, but why? Look, if we are getting the answer from right to left, we have to print the answer from left to right. So if we are getting the answer from right to left position, we need to reverse it for getting the correct answer. So that's why we are reversing the answer and then we are getting the answer. For the complexity of the code, we can see that this for loop is going for n times and this for loop too, and we are doing some basic operation in here. So the things which are happening in the for loop is O of 1. So the final complexity, this is huge, I can't do this. So time complexity is order of 2 into n, that is order of n actually. So this is what we got. Thank you, be happy and be safe. Bye for now. And if you have some problem for understanding the editorial or in the code, please let me know in the comment section.